All right, today we are digging deep into Earth's history, and I mean millions of years deep, to ask a question that is truly mind-bending.
Seriously, what if, long before we ever showed up, some other species built an industrial society and then just vanished? Could that have actually happened? And if it did, how in the world would we ever know? Okay, let's really get into this.
This isn't just some wild sci-fi idea. It's a real thought experiment called the Silurian hypothesis. And it asks a very serious scientific question. What kind of footprint would a civilization like ours leave behind for geologists to find, say, 50, maybe 100 million years from now?
And yeah, the name, it's a pretty fun nod to a classic Doctor Who episode. It featured an ancient race of intelligent reptiles called the Silurians who were around long before humanity. So with that in mind, let's start digging.
So first things first, if there was some lost civilization, what would we even be looking for? What kind of geological fingerprints would they leave behind?
The first thing you've got to realize is that any direct evidence, cities, statues, factories, all of it would be long gone. I mean, after millions of years of continents shifting, mountains rising, and endless erosion, every trace of a city would be ground into absolute dust. So we have to look for indirect clues.
And these clues, well, they probably look eerily familiar. An industrial society would almost certainly burn fossil fuels, right? So you'd see a sudden carbon spike, which would trigger global warming and a loss of oxygen in the oceans. They might create weird synthetic compounds like plastics, or leave behind spikes of metals, maybe even radioactive particles from nuclear stuff. Basically, they'd leave the exact same kind of fingerprints our own civilization is carving into the planet right now.
But, and this is a huge but, here's the catch. For almost every single one of those signals, nature has a look-alike. You can get a massive carbon spike from a series of supervolcanoes that mimics industrial pollution, and the Earth has gone through plenty of natural global warming events, these things called hyperthermals. So telling the difference between a lost civilization and just a really, really bad geological Tuesday, it's incredibly difficult.
So this whole geological puzzle forces us to pivot a little. Let's forget the how for a second and focus on the who. What does it actually take, biologically, to get smart enough to build a civilization in the first place? And that brings us to the absolutely massive energy bill of a big brain.
Okay, this is so important. Brain tissue is one of the most metabolically expensive things a body can possibly make. The power to innovate, to create complex societies, that all comes at a really steep biological price. But just how steep are we talking?
Well, for most mammals, the brain uses up about 3 to 5% of their resting energy. Okay? That's our baseline. A respectable amount. But then you move up to our closer relatives, the primates. For most of them, that number jumps to between 8 and 10%. So our evolutionary family was already spending way more of its budget on brain power. But believe me, we were just getting started.
And here it is. This is the human anomaly. Our brains, they're only about 2% of our body weight, but they consume a staggering 20 to 25% of our resting energy. That is a massive, massive outlier in the animal kingdom. Which, of course, leads to the next big question. Where on earth did all that extra energy come from?
I mean, think about it. If our total energy budget isn't that different from other mammals our size, how did our ancestors possibly afford to run a brain that cost 4 or 5 times more than the average? Well, the answer seems to lie in a pretty fascinating evolutionary bargain.
It's called the expensive tissue hypothesis, and the idea is pretty straightforward. To pay for a much bigger brain, our ancestors had to slash the energy budget for another expensive part of the body. In evolution, you just can't get something for nothing. That energy had to be rerouted from somewhere else.
The first logical suspect was the gut. It's another really energy-hungry organ. But when scientists actually looked at the data, and you can see it here on the left, they found something surprising. Primates, including us, fall right on the trend line. Our guts are exactly the size they should be for our bodies. So, nope, that wasn't the trade.
The real trade-off was our brawn. Yeah, compared to other primates, humans are actually pretty wimpy. We are significantly under-muscled for our body size. We basically traded muscle mass, another expensive tissue, for more brain mass. We became the brainy, but much weaker, ape.
So that's how we paid the bill. 2 things happened. First, our ancestors started eating much higher quality food, stuff packed with energy, like meat and nuts. That gave us more fuel. And second, our bodies evolved to divert energy away from building bulky muscle, freeing it all up for our growing brains.
Okay, so let's tie these two big ideas together. We've got this geological mystery about lost civilizations, and we have this biological story about our own really unique evolutionary journey. So, how do they connect?
Well, once that trade-off was made, once we started trading muscle for brain, our lineage saw an absolute explosion in brain size. You can see it so clearly here. Starting around 2 million years ago with the genus Homo, our cranial capacity just takes off, basically tripling in size to get to the brain we have today. This was the biological ticket that let us create technology and eventually civilization.
And this right here is the whole point. Human civilization isn't just some cultural accident. It is the direct result of a very specific, very rare, and energetically expensive biological path. Any civilization before us would have had to solve this exact same energy problem, and that would have left its own unique biological clues in the fossil record.
And this brings us all the way back to the Silurian hypothesis, but with this fascinating, incredible paradox. Think about it. A civilization that lasts for a very, very long time would probably have to become super sustainable, right? But a truly sustainable society, one that uses clean energy and recycles absolutely everything, would leave almost no footprint for us to find.
Which leaves us with this final, kind of haunting thought. Maybe the reason we don't see any evidence of a civilization before us isn't because one never existed. Maybe it's because if they were truly advanced, truly successful, they would have learned how to live without leaving a scar on their planet. And maybe that silence in the rock is the most important lesson we could ever hope to learn.